Heat flows from a hot object to cold object. Okay. And we have also watched video about three things here: conduction, convection, and radiation. Okay. Actually, we have experiment to prove this, but we need to do it in the lab. But I can give you some ideas about this experiment. So we have three thumbtacks here, KLM. You can see here, KLM. And then we have Bunsen burner. Okay, from the Bunsen burner, heat will be transferred. As we have learned just now, we have molecules. So the first molecule will be heated up. Okay, it will be heated up, and then it will be transferred. The heat will be transferred to the next particle. So the heat will finally reach the wax, and the wax will melt. So K will fall down first, and then L, and then M. Because this experiment shows that heat has been transferred. Okay, that is about conduction. The next thing is about convection. This potassium manganate crystal is actually in solid form initially. So when the reason why we use potassium manganate crystal is because of the color. It is in purple color. So when it is heated up, and then it will dissolve. Okay, it will dissolve here, and when the water at the bottom of the beaker heated up, and then it will become less dense. This is what we have learned just now. It becomes less dense, and then it will rise. Okay, but cool water will, what happens to cool water?
The cooler will replace the space where the hot water that has rises.
Correct. Okay, correct. That's correct, because hot water will rise, so cool water will go down to fill the space. So finally, we have one circulation of water. Okay, we have circulation of heat transfer. Okay, we have a circulation, and finally, all part of the water will be heated up in this process. Even though only water at the bottom is heated up, but finally all part of the water in the beaker will be heated up because of convection. Remember, the process here is convection. Okay, and this is also convection actually. Okay, what we are doing here, can you look carefully? We have T-shaped cardboard, which is blue color. Actually, there is some air space at the bottom here. Okay, it doesn't cover to the bottom. We have some space of air over there. Okay, what happens is when the candle is lit, and then we have heat energy around this area, heat energy, it heats up the air around here. So what happens is the air around here will rise because the density decreases. So it will leave empty space there. So what happens is the air from the other side of the T-shaped cardboard will flow towards this side. Okay, it will flow. And you can see glowing incense stick. It produces smoke. The reason why we need the smoke, because we want to see how heat is transferred to the other side. Okay, so you can see the smoke will flow to the bottom of the T-shaped cardboard, and then it will rise. So from here we can see the smoke will rise also finally. So we can see the circulation of air, which is represented by the smoke. So this also an experiment to show convection, but in this case it is convection of air. And the first diagram we have here is the convection in water. Can you see the difference now?
Yes, sir.
Okay, good. And the last thing is radiation. Okay, now you can see here we have a bell jar and we have vacuum pump, but the vacuum pump is not shown here. What happens is the vacuum pump will suck the air. All the air will be sucked out of the bell jar. So the bell jar becomes empty and it has a vacuum state. So what happens is when we turn on this bulb, when you put a palm on the bell jar, you, you still can feel the heat even though there is no air molecule in the vacuum pump. Okay, this actually proves that heat can be transferred in vacuum. Okay, this proves that heat can be transferred in a vacuum. Or you can say the process here is radiation. Okay, please remember that. So we have three ways of transferring radiation. Okay, this is conduction. This one is conduction. Okay, and then you have convection. This one, and we have radiation. Okay, is that clear? Okay.
Yes.
Okay, good. You can screenshot this. Okay, please screenshot the part, the upper part of the screen. I will slide up so that you can see at the bottom later. Okay, you can screenshot this one. Conduction. Have you done it?
Yes, done.
What? I cannot hear clearly. You just screenshot this one, and then I will slide up, and then you can take another screenshot. Okay, you can take this one. Okay, have you done it? Okay, so
Yes.
you can write your note later. Okay, this is what I told you just now about radiation. Okay, as we know that in the space we have vacuum there. So how heat is transferred from the sun to the earth? So the process of radiation occurs. So heat is transferred without particle, because we know that the sun is the main source of energy. Okay. Okay, let us look at another situation here. We have example of sea breeze here. This process applies convection process. Okay, you can see this is convection process. So what happens here is during daytime it is hot. It is hot on the land. So the air above it will be hot also. Okay, the air will be hot also on the land because land heats up faster than sea. So what happens is the air will rise. Okay, the air will rise. So what happens is the air from the ocean or the sea will flow to the land to fill the empty space or to the lower pressure area, and then the air from uh, from high altitude on the ocean will go down to fill the area also. So and then the air which rises from the land will move towards the ocean. So we have one circulation. Okay, we have one circulation of air. So this is what we call sea breeze. When we say sea breeze, this means that the air comes from the sea towards the land. This happens in the daytime. You can see this is the sun. So this means that it happens in the daytime. And then we have another situation, what we call land breeze. So land breeze means that the air flows, or the air blows from the land towards sea. Okay, you can see here. What happens is the other way around. At night, the ocean is still hot because you know that water can store heat. So at night, water is still hot, but the land is already cold because it loses heat faster. So what happens is the air above the sea will becomes hot, and then it will rise because the density will be lower. So the air from the land will move, will blow towards the ocean, and then the air will make another circulation like this, another circulation of air. Okay, any question about this?
No, sir.
Okay, good. So I hope you understand about this. Okay, another thing we need to see here is about heat conductor and heat insulator. Okay, this is the holder, right? Can you see this? This pen, can you see the pen there? Okay, the
Yeah.
holder, the holder here is a bad conductor. So when you hold it with your hand, you don't feel the heat. You don't feel hot. But at the bottom over here is a very, very good conductor. This means that heat from the flame will be transferred efficiently through the bottom of the pan because it is a very good conductor. So while having this situation, we can heat up the food, we can cook the food, and we can hold the holder of the pan to move it. Good. So that is one example of application of conduction of heat. Okay, this is a thermometer. Mercury in thermometer is a good heat conductor. It can detect change in temperature very quickly. Okay, when it expands, you can see the temperature rise. Okay, and then this is iron. The base of iron, okay, the base, we're talking about the base of iron, is made of metal to enable it to conduct heat, so that the cloth can be ironed quickly. And then you can see the oven glove. Oven glove here, it is a bad conductor, so heat cannot be transferred, or less heat is transferred. Actually, you at least you still feel the temperature, the heat, you still feel it, but not very high temperature. So this means that it is a what we call a heat insulator or a bad conductor. Okay, and then ice box. Ice box is also a bad conductor. So heat from outside cannot be transferred into the ice or any cold drink in the ice box. Okay, cooking utensils made of wood. Okay, it is made of wood, are capable of preventing heat from flowing to the hand while cooking. Okay, that is example of uh, heat insulator. Okay. Okay, the next thing we will learn is about thermal equilibrium. Okay, this is the last subtopic for today, thermal equilibrium. Two objects which are in thermal contact, okay, this is important term here, thermal contact, can change heat. Okay, they can exchange heat energy. Exchange heat energy. between them. The heat energy is transferred from the object with higher temperature to the object with lower temperature. So let's say you have two objects here. Okay, let's say this is object A and this is object B. So this one is hot, this one is cold. So heat will be transferred from hot to cold object. And they must be in contact. Okay, when they are in contact and heat can transfer, we call it thermal contact. We say that the two objects are in thermal contact because heat can be transferred while they are in contact with each other. Okay, what happens after a long time? After a long time, the two objects A and B has the same temperature, right? Is it true? Finally,
Yes.
has same
Yes, sir.
temperature. Okay. When it has same temperature, we call it, we say that they are in thermal equilibrium. Okay, why it is in thermal equilibrium? Because there is no more net transfer. Okay, there is no net transfer. There is no transfer like this.